isn't so seamless.
But I'd like to dive into the material today, which dovetails quite strongly with the testing side, but also starts to get into what's really the next segment of the class, which is a discussion of sort of good basic personal software engineering process issues. Particularly, we've been talking about the use of interfaces and the separation of interfaces from implementation. And along those lines, one of the key, components of understanding this is the role of when we're talking about separating the notion of an interface from an implementation, the notion of separating the promises that your code makes, or the contract that your code makes, from the details of the how, the vagaries of how you actually go about accomplishing these contracts, how you living up to the contract. There's a key need for specifying the contract, and we do this through a thing called specifications. So the contract, we specify the contract. We say what that contract is. We state what things does this code ensure. So if I have a square root operator, for example, and I give it a quote-unquote value, it might ensure that the value returned lies within a certain epsilon, a certain distance, a certain precision, level of precision from the true value. Or if I have a routine that sorts a bunch of numbers, I might make a promise that numbers that are ties remain in the same order there as they were originally included. That may sound odd, but there are certain cases where it's actually required to keep track of the order with which things have been permuted. Okay, so this is specifications time. Okay, so we're going to be talking about the motivations for this, and as we'll see, maybe this time, maybe we'll have to wait till next Tuesday. This gets into testing. Why? I'm trying to give you the really big picture of why I'm doing this. Why does this tie into testing? Anyone want to sort of go out on a limb and take a guess? Why does this division between what we're promising on the one hand and how we're actually implementing it? How does that relate to testing?
You should base your test on specification.
You got it. It's this contract. It's this thing that say, I am promising you this. I'm not promising all the details of the code. I'm not going to say whether I'm going to use a bubble sort or a quick sort or a merge sort or a rated sort or whatever. I'm not going to tell you I'm using Heron's algorithm for determining the square root or Newton-Raphson or whatever. I'm going to just say, this square root routine promises that if you give it a number, the answer it returns lies within a certain distance of the true value. That's what I'm promising, and that promise can be tested. If I make a promise, if I have a contract, you can test very readily. You should be able to test very readily, is this contract being upheld? Is it being maintained? That's where this gets into this. And if it's all gone together, you don't have a separation of a contract from the code. If you just say, well, my code is my contract. Look at my code, and that's what it does. It does what it does. It's hard to test code because you don't know what you're supposed to be testing. What is it supposed to accomplish? And some of the Prescient members of this class had noted that in some of the examples I gave earlier, where I was appealing to intuition, what was really lacking was a clear specification of what this code was supposed to do. how can I say is the scope broken without knowing what's it supposed to do? Not all the details of how it does it, but what general purpose does it accomplish? And that, ladies and gentlemen, is what's specified in the contract. Right? So this may sound like a diversion from, or may sound like a digression from the issue of testing that we've been talking about, but it's going to all loop around. I'm hoping that loop will be closed at the end of this lecture. If it's not, that will remain until next Tuesday. Okay? But that's how all this stuff happens. Now, at a very prosaic level, this gets into the issue of practices and sort of standard procedures with programming in the small, for example, with C. So in C, we have a classic separation of .c files from what? Header files, .h files. And this is where the contract should typically live in C. Now, in really well-structured, through C programs, these contracts are very, very explicit. They're written out in comments. Sometimes formal languages are used to describe them, to provide guarantees. For example, to provide a guarantee, this routine will never return a null value. Or it only works if you give it a non-null pointer, in which case it returns such and such. But even if you're not using formal specifications, or even really carefully constructed informal specifications, the .h file is often where the promise is implicitly omitted. Okay? It's through the naming of the routines or the extra documentation provided through them. So there's a separation of the interface from the implementation, and someone can use your .h file and call off your routines and never have access to your .c file. How could that happen? How could it happen that you could give me a routine that I can call, I can see its .h file, you give me the .h file, but I can't see the .c file. Could that happen? Okay, give me an example. What's a routine that you folks have called, you've seen it in a .h file, but you've never actually seen its implementation, its .c file? Okay, yeah. Maybe there's a routine called correct, but there's certainly a process or a program called correct. There may be further a routine called that. What's another routine? Yeah. Spur copy, calc. How many people here have seen the source code for calc? How many people here want to see this? Okay, I might want to see it, but the fact is, we reuse a lot of things without seeing all the gory details. We reuse a lot of functionality without seeing the details. What we do see, ladies and gentlemen, are the statements of what it does, the statements of what it accomplishes, what it expects as arguments, what it returns as values. And, you know, that's something that's specified in an .h file, in addition to other documents. Okay. So if you're looking for tools to get started with C programs, one of the important emphases to keep in mind is that there's a separation of the implementation of the .c file, which you may or may never see, from a .h file, which you may circulate very, very widely because you want people to be able to use your routines. You want them to be able to use the functionality you provide, even if they never get a chance to see this .c file because it's copyrighted or something like that. Okay? So that's a high-level statement of where we're going with this. And we're going to be seeing some examples of it. So let me just